In this video, we are looking at finding the vertex of a quadratic or parabola. Okay, keep in mind that if you have a quadratic, f of x equals ax squared plus bx plus c, the leading coefficient tells you if the graph points up or down. If a is positive, the graph points up, and the vertex is a minimum. Remember, vertex is a point, and we always call it h comma k. If your leading coefficient's a negative, the graph points down, and the vertex is the maximum point, the highest y value. Okay, vertex is the point, not a number. Vertex is a point, h comma k. We find h using opposite of b over 2a. Remember, h is an x-coordinate. Vertex is a point. H is the x-coordinate of that point. To find a y-coordinate, we always, pretty much in every situation ever, plug in the x we already know. So once we find h to find k, we just plug that h value we just found back into the function and find k. So for example, say we've got this guy here. F of x is x squared minus 6x plus 8. We're looking for the vertex. H is the opposite of b over twice a. So here b is negative 6. The opposite of negative 6 is positive 6. A, the number in front, is 1. So twice a would just be 2. 6 over 2 is 3. That's half of the vertex. Vertex is a point, not a number. So to find the other half, we plug this h we just found back into the function. So k will be f of 3. 3 squared is 9. 6 times 3 is 18. Negative 9 plus 18, 9 minus 18 is negative 9. Plus 8 is negative 1. So the vertex is the point 3, negative 1. We can see that here on the graph. Notice a is positive 1. The graph's going to point up. And the vertex is here at the bottom, the point 3, negative 1. Okay, we know standard form of a quadratic is f of x is ax squared plus bx plus c. If we're using quadratic formula, if we're completing the square, even if we're factoring, we want this form. Another way we could write the same quadratic we call vertex form, and it's nice because it has the vertex right in front of us. It's f of x is a, same a as before, x minus h squared plus k. We want to think of this just like graph transformations. We have the regular graph x squared. We've shifted over h and up k. The h is inside, k is outside. Inside is always a horizontal shift, so that changes our x value. Outside is a vertical shift, that would change our y value. Notice there's a minus built right into the formula here. So my h value, the x-coordinate of the vertex, is whatever comes after this minus. Okay, so say for example, somebody gives us the quadratic f of x is 3, x minus 5 squared plus 2. Then the vertex is right in front of us. The vertex is the point 5, comma 2. But that's a negative 5, you're saying. Exactly. H is whatever is after the minus. This is x minus h. K is whatever is outside. Opposite of what we see inside, the same as what we see outside. Another example. If we had f of x is negative 4, x plus 8 squared minus 7. Then the vertex would be the point negative 8, comma, negative 7. Why negative 8? Because vertex form is x minus h. I have to look at this as x minus a negative 8. Or another way to think of it is h is the opposite of what we see inside the square. K is the same as what we see outside. Okay, so let's say we've got some function that's in standard form, ax squared plus bx plus c. And we want to convert it over to vertex form. We want to write it in this form, a x minus h squared plus k. Well, we need to identify a, h, and k. Okay, well, a is easy. A is the same thing that's sitting in front of the x squared, so a is just 4. That was easy. H is the opposite of b, so negative 24 over twice a. Twice a would be 8. H then would be negative 3. To find k, we always plug h back into our original and solve. So k is f of h, f of negative 3. So negative 3 squared would be 9 times 4 is 36. 24 times negative 3 would be negative 72 minus 3. We get negative 39. And then we write the function in vertex form. F of x is a, 4, x minus h. So I want x minus a negative 3, that's x plus 3, squared, and then plus k. K is negative 39, so minus 39. Okay, that's vertex form. Click on any of these other videos about quadratics to learn more.